All right, in this video, I'm going to go over some hints for worksheet 7.1. So here we go. Let's take a look at these. So for the first one, basically you have this force versus stretch graph, and you have two different springs on there, and for each one, it says determine the spring constant. Remember the spring constant, which again is that k value, like it's k, that's the slope. So basically you're just trying to find the slope of each of those lines. For part B, there's a couple different ways you could do it. Since it is 3 meters, 3 meters is on the graph, so you could just draw upwards until you find it. You could also use f equal to kx for each of them, and just plug in the k value that calculated for A, and then the 3 meters for x. So either or, again, you can kind of use the graph, or you can use the equation. Either or, it doesn't really matter. Let's see here for number 2, you might find, again, drawing a force diagram might be kind of useful. Obviously, we have gravity straight down and normal force upwards. We would have the force of the spring in that direction, and then this force F, which is applied to the right. And basically, it's asking you to find that force, but because that force is going to be equal to the force of the spring, right? F is going to equal the Fs, the force of the spring. So basically, you just need to calculate the force of the spring, right? So that's just kx, k, x, pretty easy. Next one, it's a little bit more difficult, but not really that much more difficult. Basically, almost identical in terms of the force diagram. However, the biggest difference here is that basically, so like let's just say, force of friction is going to basically hold it out, and the force of the spring is pulling it in, and we want to know when those two are equal, right? If you push it too far to the right, then as you push it to the right, that's going to make Fs bigger and bigger and bigger, right? Because the force of the spring is kx. And so as you push it to the right, the x gets bigger, so therefore s gets bigger. And the question is basically what is the furthest to the right that you can push it? So again, that's basically going to be when Fs is equal to Ff. So when that is true, and so obviously Fs is equal to Ff, and you're given Ff, right? So you know that that's 3.9, and so and that is kx. So just solve for x then. So the last one is definitely the most difficult, and I would suggest that you just kind of draw yourself a force diagram to start things off. Obviously, normal force and gravity. Then as you read it, right, a large crate is being pulled to the right. So we got our Fs here to the right. And then we got a factory worker, which is pulling to the left. That's going to be 200 newtons. And then we have the force of friction, which is 49. We need to figure out which way the force of friction is. Is it to the left or to the right? And so in order to do that, we need to figure out whether Fs is bigger or smaller than the 200. So I drew it as bigger, but let's see what it is, right? So that's going to be 500 times by, it's stretched 1.5 meters, right? Because of course the problem is friction was going to go to the left if Fs is bigger, or if this is less than 200, if Fs is less than 200, then friction is going to go the other way, right? Because it's a resistance force. So let's take a look at this. 500 times by 1.5 is going to be 750. So, right, so that means because 750 newtons is bigger than 200 newtons, the force of friction is going to be in the opposite direction, 40. That's going to be to the left. So then it says find the resulting acceleration. So you sum your forces in the x direction. We know that it's going to accelerate, so you're going to put ma, and then you have forces to the right minus your forces to the left. And you can solve for your acceleration. So hopefully that helps. Once you get the hang of it, not too bad. So good luck, and yeah, we'll talk to you later. And of course, as always, let me know if you have any questions.